In the diagram, it says, in the diagram below shows a water tank, which is made out of a cylinder and a cone. And then we have equal radii. So the cone and the cylinder, they both have equal radii. The height of the tank, so the height starting from here to here, they say which is this thing, it's going to be 1,8. So starting from here to here, it's 1,8. And then they went on to say the angle between the perpendicular height and AB. So this angle here, they're talking about this angle here, they say it's 35,5, okay? And then they say the slant height, it's AC. The conical section, it's the angle between the perpendicular height and the conical section is 35,5. So they gave us the formulas here. So you have the formula for the volume of a cone. You have the formula for the volume of a cylinder. You have the total surface area of a cone. You have the total surface area of a cylinder. So all these things are given. The first question says, calculate the perpendicular height of the cone. So let's take out the cone. This is the cone on top again. So what you have something that looks like this here. I guess this is 90. And then this one here, we were told this is 35,1,5. And then at the same time, we are told this is A, this is B. And then they say this is C. But here, from here to here, they say this is going to be what to be 0,5. Everyone is happy there. And then the first question says determine AP. AP is the perpendicular height. How would you determine AP? Now, usually we will say to learners, a learner can do that if they know what is this, if they know what is this, they can use theorem of Pythagoras. But here they are given an angle. For the fact that they are given an angle, they can use trig ratios, which is so, ka, to, like this, okay? So what do they have? They have something which is opposite to 35. And then they are looking for something which is adjacent to 35. I agree this one is the hypotenuse side. If this one is the hypotenuse side, this one is adjacent to 35,5. This one is opposite 35,5. Okay? So which trig ratio seems to have opposite and adjacent? Which trig ratio is that? So they're going to use the 10 here. And then what are they going to say? They're going to say the tan of 35,5 is going to be opposite is 0,5, okay? All over AB. Cross multiply again. If you cross multiply, it says you have AB, the tan of 35,5, which is going to be 0,5. We want AB. What can I do from it? I can divide both sides by the tan of 35,5. Okay. Even this side, I'm going to divide by tan of 35,5. This one and this one, they divide each other out. Okay? And then you take out your calculator, you type this thing. If you type this, you're going to have 0,5, okay? All over the tan of 35,5. And then we get what? So it says AB is going to be equal to 0,70. 70. Yeah, this is going to be 0,70 if we round off to 2 decimal places. Okay, we can come and tell them, okay, now we know this one. If this one is 0,70, this one is 0,70 meters, okay? And then this one is also going to be 0,7 meters. Now, what did I say here? Let's look at this. They said starting from here to here, it's 1,8, okay? So what is going to be the height from here to here then? What is going to be the height from here to here? If we know which this one is 0,7. Yeah, this is going to be 1 meters. No? Now, when the tank is full, guys, full volume. When the tank is full volume, actually, we are filling the tank. What are you filling the tank with? We are calculating the volume there. We're not interested in the material which made the tank. We are going to be talking about the volume. Now, what do we have here? We have the volume of this coin, okay? And then we also have the volume of a cylinder. Even if we don't understand what's going on here, Muhau, because they talk about when the tank is full. Before we go to the English, we'll go to the English after that. Let's go and calculate the volume. Volume of a cone. What is the volume of a cone? It's given by, we are given the formula. 1/3 pi r squared h. Okay? This is going to be 1/3 multiplied by pi. Okay? Multiplied by r. What is our r? They gave us r. R they said is 0,5. Okay? So this is going to be 0,5. We're starting with the cone. And then the height of the cone, we code it as 0,7. Remember this, okay? So this is going to be 0,7. And then you type this in your calculator. Let's check what you get. You get 1/3. Okay? 1/3 multiplied by 0.5 multiplied by pi. Multiplied by, oh, sorry about that. I need to square this thing. 0.5 squared. And then I also forgot the pi. Okay, let's start with the pi first. Multiply by shift pi. Multiply by 0.5, and then this one we square it. Squared multiplied by 0.7. 0.7, like this. And then we get 7 all over 120 pi. And then if we round this off to 2 decimal, it gives us 0.18. 0.1832. And then this is going to be meters cubed, like this. Okay, let's get the volume of the cylinder. What is going to be the volume of the cylinder? The volume of the cylinder is given as pi r squared h again. So it's pi r squared h, like this. So we have pi, we have 0.5. Yeah, it was supposed to be squared. 0.5 all squared multiplied by 8. Our h here is not 0.7, but it's 1.1. And then we go and say, okay, what do we have? We have pi, shift again. Pi multiplied by 0.5. All squared, multiplied by 1.1. Like this again. And then you get 11 all over 40 pi. And then this is going to give us something like, let's check, 0.8639. Okay, what is going to be the total volume? Plus, we add here. What is this thing? It's 0.1832, like this. And then we get 1.05, which is going to be meter cubed. So we got the volume again. So this tank can be filled with 1 meter cubed again. But an 1.05 meter cubed. Yeah. When the tank is full volume, an electric pump switches on and pumps water into the tank. And pumps water from the tank into an irrigation system at the rate of, it's going to be 0.52 meter cubed per hour. Yeah, not squared. Yeah, it's meter cubed per hour. And then the pump switches off automatically when the tank is 1 all over 4 full. Now, calculate how long in hours the pump feeds the water into the irrigation. So if, look at this, guys. Agree, what is the volume that we have? We have 1.05 again. And then this thing here is going to switch off when we've used 3/3, because it switches off once this tank, it has a quarter. So let's say which you have a tank here. In this tank, agree the tank has 1 all over 4. So you have 1 all over 4. So the tank is going to switch off if you are remaining with 1/4. So if we are remaining with 1/4, the tank switches off. That's what they're saying here. The English here, I'm trying to interpret the English here. They say the pump automatically switches off when the tank is 1 all over 4 full. What does that mean? It means the tank has used what? 3/3. So the tank has used 3/4 of this thing here. So now we're going to get what is going to be this 3/4. What is 3/4 of this thing? It's simple. We're going to say 3 all over 4 multiplied by this. So what is going to be 3 all over 4 of this? So you say multiply by 3 all over 4. And then you get what? 0.776 79 meter cubed. So when you have used 0.79, this thing switches off. Now, here what you are given which the water is losing 0.52 meters per hour. So to get to how long is this thing going to take? How long? We are going to say it's 0.79 meter cubed all over 0.52. Again, this is meter cubed per hour. Can you see that again? The meter, for those who are doing physics, they will tell you which the meter and the meter, they will divide each other out. And then this is what you're going to be remaining with them. You're going to take this and then say answer divided by 0.52. Then it's 1.5 hours. So it's going to cost 1.5 hours. Approximately 1.5 hours. Then this thing is going to switch off.